step up from our core understanding of variables to look at data structures. We'll then examine some basic data structures as well. Last time around, we learned about variables and values. You've seen how a variable can hold a value. Computer programs work with large amounts of data at a time. Imagine a banking software that must process millions of transactions, or a search engine like Google, which must sift through billions of records efficiently to produce results. Inside a computer program, this data can be operated on in several ways. For instance, you could create new pieces of data, read existing data, update existing data, insert new elements within an existing set of items, delete data, search through data to find something specific, or even sort data based on a condition, such as browsing through a list of restaurants with the highest rating. To ensure these operations are done efficiently, data must be organized into efficient structures, which are collectively known as data structures in computer science. Even in real life, we organize data for easy recall and use. For instance, we use lists for managing things to buy or tasks to do. Accountants use spreadsheets for managing financial data. Organizing data is essential for efficient consumption and processing. Every programming language lets you organize data into structures, and the choice of a structure often spells efficiency and performance for the operations we discussed earlier. There are several data structures in computing, such as stacks, queues, lists, trees, graphs, and more. The objective of this video is not to deep dive into all these structures, but to merely introduce the concept of a data structure with easy to understand examples. You will learn about all kinds of data structures later in your program. So in this video, we'll quickly talk about stacks, arrays, hash maps, and queues as data structure options. Bear in mind that this is going to be a high-level overview of these structures for the purposes of understanding their use cases and features. So first up, let's talk about stacks. A stack is precisely how you would imagine it to be. Imagine stacking up boxes. To add a new box, you simply add it to the top of the stack. And this is also the first one to go when you have to remove a box. This behavior is also known as last in, first out, because the element that goes in the end also goes out first upon removal. Stacks are a great example of linear data structures where elements are stored in a sequence. A classic use case of stacks is implementing the undo functionality which we get in applications like word editors such as Microsoft Word, or image editing applications like Adobe Photoshop. You perform a series of tasks and they get stored on a stack. When you hit undo, the last performed action is the first one to be undone and removed. This is what last in, first out is all about, and stacks are a great way to implement such a feature. Now, this discussion on stacks brings us to our next data structure called arrays. Most languages offer a data structure known as an array, which can work like a stack, allowing you to house a collection of items in a sequential fashion. Let's use JavaScript as the language to demonstrate. Here you can see an array of fruit names as strings in an array. Note how a single variable is able to store multiple items in a collection. Every element in an array has an index number associated with it. You can think of an index number as house numbers in a street. The index number is sequential, often starting from 0 and going all the way up to the last item. And this number is used to access a specific item. For instance, at index number 0, we have the word apples, while at index number 3, we have kiwi. You can add, remove, update, and reorder items in an array by using these index numbers. An array, like our fruits array, is known as a one-dimensional array. Arrays can also be expressed as two-dimensional arrays as shown here. This is essentially arrays inside arrays. To access elements, we can use the notation shown here. You can see how the index numbers are put to use when you want to access specific elements. When an item is added, it is added to the end of this structure, as you can see here. This is known as pushing an item into the array. When you have to remove something, you have to pop an item off, in which case the rightmost item goes out. This is exactly what you would do if you had a stack full of boxes. You would add new boxes on top and you would remove them from the top as well. Hence, last in is also the first one out. In programming, an array as a data structure may be used to hold multiple items of data, such as lists of employees or students in a class, or a list of social media posts, a cart full of products that you've purchased, and so on. As you can imagine, arrays are incredibly useful when working with multiple items. The next data structure that we'll see is a hash map. Unlike an array, a hash map consists of key value pairs. Consider the table shown here. Let's say this data represents a user. We have the name, age, and profession. And we can also include other things like an email ID, postal address, etc. In a hash map, the elements on the left are keys, to which we have corresponding values. Every key has a value. Hence, hash maps have key value pairs. As an example, in JavaScript, we have objects which behave like hash maps, allowing us to store key value pairs. Accessing or manipulating data is done by using the keys for identification. And here's something interesting. You can use an array to store multiple hash maps or objects in our case, and this is something you'll get to work with when you learn JavaScript or other languages when you build your apps. Accessing elements in such a case involves accessing the object first. Here you can see we are accessing the object with the index number 1, which represents Jane Simpson, and then we are accessing the value of the property or key named designation, and we get the value. Our next data structure is known as a queue and is quite simple to understand as well. A queue is just like a queue outside a store, where the interesting thing to observe is that the person at the front was the first one to arrive and will be the first one to exit the queue as well. Likewise, in traffic, the car that gets in a lane first is also the first one to get out. Therefore, a queue, unlike a stack, is a first in, first out data structure, where the element that gets in first gets out first as well. Since we are using JavaScript as an example, an array can be made to behave like a queue if we remove the item from the left-hand side of the array, which is also the first item to go into the array. In the case of a queue, adding an item to the queue is known as enqueuing, and removal is dequeuing. Queues also offer a few other operations such as peek, which lets you see the elements sitting at the front of a queue. You can also check if the queue is empty or not. A great use case of a queue data structure is a playlist in applications like Spotify. As you add songs to a playlist, they keep getting added to the list, but the songs will play from the top. That is, the song added first will be played first, in line with the first in, first out approach. Alright, with that, we have come to the end of this module. In the next module, we'll continue our exploration of computer programming by learning more about building blocks of code using a syntax called pseudocode.